it is possible to measure real power in a three-phase unbalanced load using a single-phase wattmeter. However, this method requires careful considerations and assumptions. The assumptions are: firstly, the phase angles of the voltage and current waveforms are known. Secondly, the load is balanced, or the current magnitudes are close to being equal. Thirdly, the voltage across each phase is the same. The procedure is as follows. 1. Measure the voltage across each phase. Use a voltmeter to measure the root mean square voltage across each of the three phases. 2. Measure the current in each phase. Use a single-phase wattmeter to measure the current and power factor in each phase. Record the following values. Current magnitude is I, phase angle is theta, and power factor is PF equals cosine of theta. 3. Calculate the power in each phase using the formula P equals volts times amps times power factor. For the calculation of total real power, 1. Sum the real power measured in each phase. P total equals P1 plus P2 plus P3. 2. Use the correction factor if the load is unbalanced. If the current magnitudes are significantly different, apply a correction factor to account for the unbalanced load. Correction factor equals 3 times smallest I divided by the sum of all I. Adjusted P total equals P total times correction factor. For example, assume the following measurements for an unbalanced three-phase load. Volts 1 equals volts 2 equals volts 3 equals 120 volts. Amps 1 equals 10 amps, theta 1 equals negative 30 degrees. Amps 2 equals 8 amps, theta 2 equals 20 degrees. Amps 3 equals 6 amps, theta 3 equals 60 degrees. Calculated power. Current equals 120 times 10 times 0.866 equals 1039.2 watts. P2 equals 120 times 8 times 0.939 equals 905.28 watts. P3 equals 120 times 6 times 0.5 equals 360 watts. P total equals 1039.2 plus 905.28 plus 360 equals 2304.48 watts. Correction factor. Smallest I equals 6 amps. Correction factor equals 3 times 6 divided by 10 plus 8 plus 6 equals 0.9. Adjusted P total equals 2304.48 times 0.9 equals 2074.3 watts. Therefore, the estimated real power for this unbalanced three-phase load using a single-phase wattmeter would be 2074.3 watts. Note that this method is only an approximation and may not provide accurate results for highly unbalanced loads or complex waveform distortions. For precise measurements, it is recommended to use a 3 wattmeter method or a power analyzer.